So, how to select a biometric state? Which biometric state will be useful for our activity, right? So, one way by till now what we understood that there are false acceptance rate, there are false rejection rate or equal error rate, right? These informations are known to you, or you have the threshold. For each threshold you have the different FAR and FRR, and based on that you would like to select a biometric state, but that is not a correct way. Only error is not a sufficient thing. There are several other issues. Now, first part you have to keep it in mind that what for you are introducing the biometrics device or biometric state, that has to be known to you. That what is the application, why you would like to use it, what you are going to gain throughout from this, all those things to be studied carefully. So, you need to know what is the requirement and specifications. Where you are going to implement is also, suppose I want to implement it for this classroom, I know this is the classroom size is 100, this is there are 2 doors and 1 door will not be open. Suppose it may so happen that every chair I keep one biometrics device and you sit and you give your fingerprint, right? But is it worth that 100 biometric fingerprint scanner I am putting it for a classroom of size 100 and each cost 8,000 rupees or so. So, what is the value? How many of us will be using it? What I will be gaining? All those things to be studied, right? So, the requirement is the most important part you have to understand, and once you know the requirement, there are few factors you have to keep analyze carefully. First one is of course is the cost, right? Because if it is 8,000 rupees and 100 chairs for a classroom, it is a very costly thing, because it is a 8 hours lecture, and for that 8 hours 100 students, suppose my classroom is full and you will find that I will give only one fingerprint which takes 10 seconds. So, 10 seconds, 8 class, for each fingerprint it will be used only 80 seconds, rest of the period it is idle, right. So, cost versus time will be a problem. Then error rates, of course error rate will be a, because you have to understand the depth of the security you are looking for. Based on that you have to select what type of error rates is acceptable for you. Then speed, how much time it takes, right, to accept the data, to analyze the data and so on. Is it acquirable? That suppose I use the sensor for cultivators, a fingerprint sensor, then it may so happen that most of the time it is not accepting the data, right. So, acquirability is an issue. Then privacy is most important, that whatever data I am giving you, how safe it is completely known to the system only, not others who, right, and is it easy to use. For example, in the classroom, if I think that no, I take iris data, you will find that it takes, or 4 fingerprint data, it takes a lot of time. It is not easy to use. Whereas if I take the face photograph, nobody will be disturbed. I will take automatically your photographs without your knowledge also. And then the manager or the industry employer, they have also biasness with respect to the system. Recently, one party came and they wanted to use the biometric system. I asked what for, they told that it is for the recruitment purpose. Then I told okay fine, then but it is a fingerprint is sufficient for you, or you take the signature, this is sufficient for you, take the photograph, sufficient for you. But this man is biased towards IDs. He is giving the pressure, no, we want to use the IDs. I said, what for you want to use the IDs? There is no value, because he understands from the book that IDs gives you the best results. In the case of recruitment, say if I take the fingerprint or the face photograph, that is sufficient. Why I am claiming to, I explained to him, see that I take the photograph and then it is not final, that he is just appearing a written test. You take his photograph and you will be getting enough chance to monitor him, because after that if he clears his test, then you will be calling for interview. Again you take the photograph. Then even if he clears it, then again at the time of joining also you can take his photograph. So you have enough time to monitor that candidate, so iris is not required. But it is no. So this is an important parameter, that you not only all these factors, that people's mentality also important. Now that once you understand that for any biometric state you need a sensor. So you have to understand what is the property of the sensor. Is it matured enough? What does it mean? The matured enough means that it is stable for, or it is well accepted, that sensor is well accepted by the society for long time, right? And there is enough research has been done to draw the conclusion that this sensor, this type of sensor gives you the unique characteristics, because that is the important thing. So this is the most important component, is the maturity. See, for example, it is true for any hardware devices we purchase. It is not only the biometric sensor. Suppose we like to procure the system 300 PCs for our lab. Now what we do? Procedure is that first we go for the manufacturers and check what are the new PCs available, new type of available. Now we don't go for the most recent one, because we don't know how much robust it is, right? Because if it fails, then my 300 PC gone and my money will be in problem. So what we do? We take the one level below, which is already stable. People understand that yes, it has been studied, and people you have accepted, and then you are taking it. And not only it gives you the idea of the robust thing, also you are getting the idea of the cost, because as time goes, the cost of the system also goes down. So one level minus is the appropriate way of selecting, because the maturity is the issue. Now sensor type is the next one. Now you decide the system, because employers, they always give the pressure that I want the system of this type. Is it the contact one or it is a non-contact one, right? That means what? That contact one means that I have to touch the sensor to give my biometrics data. And in that process, if I have to touch it, then that I need my cooperation. I have to give full cooperation to give my biometric data, right? And also that the people will be knowing that I am collecting your biodata or collecting your biometrics, right? So this is one thing. That first thing is that in the contact thing is that I need the full cooperation from the subject. Second thing is that the subject will know that I am collecting your biometrics information. And non-contact is that it is not required. You may know, may not know. I am collecting your data. For example, I have put the surveillance camera and you are coming and I am taking your photographs without informing you or after informing you, right? Now the contactless sensors are very easy. Just I am putting it and I am taking your photograph one by one and so on. But there are two factors involved in that. One is that it gives lot of errors compared to the contact one. Another one is that it involves lot of costs. So for example, I put that you have a PTZ camera here, no, in front of your entry point. Have you seen that camera? Now suppose it is working. I don't know whether it is working or not. Do you know whether it is working or not? You try to steal something, then next day you will know whether it is working or not. Most probably it is not working, right? see what happens if I put the PTZ camera. First thing is that I need to keep the data for X amount of hours, right. Suppose I keep my PTZ camera on from night 8 o'clock to morning 5 o'clock. I do not think that people keep it on all the period. Let us keep it. Now, the volume of data you will be storing is huge. For any, suppose I assume that I have a system, any change in the scene, then my system clicks and starts recording, right, because I cannot record it all the time, then data will be huge. Only thing is that whenever there is a change in the frame, I start recording till that again it becomes the static one, right. Then also that volume of data will be huge. Huge means I do not know how to handle this information. And in reality, if you see, the data quality will be very poor, and it is not easy to analyze those data. Say for example, recently we got one data, it has been taken from the CCTV, right, and it was for the three persons were riding on a motorcycle with gun and other things. The gun is visible. To 3 persons sitting on the motorcycle also visible. Speed of the motorcycle is also visible, or you can easily determine because I know the distance. I know the other informations that there are some people looking at them, those are also there. But I need to get the face, which is very difficult, even though they could detect the 3 persons, but face getting itself is a very difficult thing, because rule is that in the motorcycle you have to wear the helmet, that helmets are there, and on that helmets there is a glass cover. So everything is gone, it is a useless information for me. So that's why contactless sensor, you have to understand where you are going to use it, right, and then only it will be useful for you. Now the sensor size is also another parameter. See, suppose I want to get information or something from you over a table, right, then I do not need a bigger sensor to show it publicly that I want to take something information from you. Instead of that, I will be taking the hidden camera and I will be sitting and discussing with you. So sensor type is very small. Now, if the sensor size is small, obviously you will be getting the small informations, resolution will be poor, right, there is a limitation on it. And if we need the larger sample sensor, right, sometimes it is required, then I need a very good resolution, right, and good coverage of my system, biometrics informations, right. Of course, in that case you need the larger one. Say for example, I want to get the palm print informations. I need the larger sensor. I need the, say I want to get the force lab data. So I need the larger information, but if I need only single fingerprint, then I do not need the force lab size sensor. I need a very small size, right. And also suppose I put the larger sensor, because say PTZ camera I put for surveillance, and cost of a PTZ camera is roughly 2 lakh rupees. So it is a very costly installation, and what I can do, if I know that there is a PTZ camera, because intruder will be always knowing that whether there exists some such type of thing. So I like to create some problem there, right. So I need to put some secured environment so that it is not physically destroyed. I say I cannot put a gunman there to keep each PTZ camera in safe condition. What I will do, I may make a iron frame, inside I will be putting my things, all those things will be coming in between, right. So, security of the physical security of my larger sensor is also an important parameter, and as a result the cost of the sensor becomes high. Now, the sensor cost is dependent on the size of the sensor. If the smaller size sensor, the cost is less, larger size is costly. Now, this is again one thing you remember, the cost is, physical cost is going down of each sensor, that is true. But you know, this is not true for only one sensor, all type of sensors, their physical cost is going down. So, relative change, cost change is not that much change, there is no change with respect to the relative cost, agreed? Yes. So, that is also important parameters. Template size, you know, smaller the template, better is that you need a smaller portion. You know what is template? Template is nothing but the features you are extracting from your biometrics characteristics. Now, these features, if the number is very less, then storage will be less. If number of length of the template is large, storage will be more, right. Now, suppose you have your smart card, right. In that smart card, you have some chips, right. What is the size of the chips? 32K or maybe 16K. I don't think it is 64K. So, in the 32K, you want to put your fingerprint informations. How many fingers information you can keep? How many minutia points you can keep, right? Because the minutia points is nothing but your x, y and theta, and all of them, each of them is of 4 bytes informations. So, to represent one minutia point, you need 12 bytes. So, how many minutia points you can keep besides your name, roll number and other things. So, smaller the size of your template, it takes the smaller area, and of course, it creates more problem for you, because you will not be able to store more number of features, and as a result there is a chance of error. And smaller sizes that IDs we will be discussing, you will find that this is nothing but it can represent using the bit vectors. So, it is a 1 bit and so on. So, IDs, even though it looks a bigger size, but the size is very small compared to the voice, because voice you need the features from the some A to B length of your speech. So, there exists a trade-off between the time and the template size. Scalability is another parameter what you have to keep it in mind. Whatever algorithm or system you design, and obviously you will not be designing that system in the field, you will be designing in the lab environment. In the lab environment, database size is small, small means very small compared to the real life scenario. And in the lab environment, you will be determining your FAR and FRR and also equal error rate, and then you will be claiming that my system has this accuracy, right. Now, once you transfer this thing into the field, database size is huge. It must be scalable. You must be able to run that one under that condition. Not only that, you must ensure that your FRR and FAR they are same as you claimed at the time of selling your product, right. So, that is the scalability part, you have to keep it in mind. A poorly scalable system is that it works very well in the lab, but while I take it in the field, it starts creating all sorts of problems. So, you understood that these are the issues you have to keep it in mind while accepting a biometric system. So, but it is very difficult to answer the question which one is the best system. In order to understand that one, you have to, or you have, in order to use that one, you have to explain yourself, or you have to understand what is the application of your system. And some of the question you ask to the users, one is what is the protected asset? What for you want to use your biometric system? Why do you need such a system? That what is that asset? That you have to understand. Who will be authorized users and operators who will be coming into that or using that system, and who will be managing the whole environment? Who are the adversaries of applications? That means, who will be getting the benefits from this system? Now, benefit can be positive way, can be negative way. The negative way means that if something goes wrong, then I am in problem, or if something goes wrong, then I may be benefited, I will get extra money for that. So, in both the case you have to understand, because you have to monitor them also. What can be the cost of the security violation? If by any means there is a security breach, then what happens? How much loss you will be incurring? That is required to know. What is the actual cost of the security? Now, you will be deploying some biometric system. Now, what will be the actual cost? Because that should be, if that cost is very high, right, because this cost is dependent on this cost. So, you have to understand that how to manipulate this one, and what is the added cost of inconvenience. If you start doing that, false rejection rate is high, then inconvenience will be increasing. What is that cost? Now, OMN's taxonomy of biometrics applications are based on these parameters. First, you understand whether you like to implement a system which is cooperative basis or non-cooperative. That means, is it expected that users will be giving his biometric informations as and when required, right, happily? Whether they will cooperate with you to give his data. Say, for example, I ask that in order to draw the money from the bank, you have to give your biometric data. You will be always happy, okay, let me give my biometric data so that I get my money. So, my money will be safe otherwise, right. But if I tell that if you prove that you are the person, then I will take 100 rupees from you, right. Then in that case, you will not be cooperative. You don't like to cooperate, because I have to, if by any means it is matched with my biometric set data, then I have to pay 100 rupees. So, I will not be interested. So, the cooperative versus non-cooperative one issue. Then overt versus covert. Overt is that I know that you are collecting the data, so I will be little serious, right. If I tell you that I am collecting your photographs, you will be serious. You will be putting some talcum powder on your face and other things, so because somebody is taking your photographs. And another one is that no, without your knowledge, I am collecting your photographs, right. That is the covert. So, you have to understand these two also, which one you want, habituated versus non-habituated, right. What it tells that signature, suppose, if you sign on your checkbook, you are habituated to sign it, and that if I see your signature, 10 signatures, you have signed at different instant of times, you will find they are almost similar in nature. Now, if I give you that no, on signature on the paper I am not accepting, you have to sign digitally. there is a digital pad and digital pen, you sign on it, where while you are signing it, you are not it is not possible for you to see what you are signing, only it is showing in the display board. So, display board is showing you that what you are signing, and in the pad you are signing it. So, you are not habituated with this type of environment, because we are habituated with that. Whenever I am signing on a paper, I see what I am signing, right. So, as a result, what happens that you will find difficulty to sign on the digital pad. You are not habituated with this environment, right. So, same is the case with the fingerprint, right. If I tell you give your fingerprint, you can give it happily, and you know that this is very simple, you just put it, and so it does not need much. But if I take that one in the village area, they will come with, after cleaning all these things, then they want to put it. Sometimes they will put the finger little below the sensor, some of them will put above the sensor, all those things will come in between. So, they are not habituated. So, you have to understand that what is my subjects, whether they will be able to give me these informations. Attended versus non-attended. Where are you going to use this system? Do you want to put somebody to monitor that whether he is giving the data correctly or not? Or it is sufficient for me that I want to put a PTZ camera and I am capturing the data. So, attended versus non-attended issue you have to sort out. Standard versus non-standard environment. What it means? That is it under lab environment or it will be in the open field. If it is an open field, then you have to understand that issues of atmosphere is coming, then your sensor must be such that must be one that which can take care -5 degree or -7 degree to +50 degrees, because your sensor should be deployable to every places under this condition. Similarly, humidity will be affected, all those issues will be coming. So, you have to understand that one also, and then public versus private. Are you going to use it publicly or in the private on this room itself only, right? Because then system will be different. And open versus closed. Open versus closed means the database, whatever you are considering, is it open or it is closed? What is open? Open means that in the database, if you have n number of people's biometrics information, the person whoever will be coming, he will be one of them is your closed database. And the person who is coming, he may be one of them or may not be in that database list, that is open. Say for example, I get a dead body, his face is there, and I got the dead body inside the campus. Say. Now, is he a person in the database? It is an open database, right? Because he may be in my share or he may not be there, right? But if I assume that in my classroom sitting people, their database is closed, this is closed because you are in my classroom attendance list. So, if you understand, if you ask these questions to the employers or the customer, you will be understand that which are the biometrics suitable for this activity. Once you know, then you will find that only few will be there. Now, the cost for acceptance error rates and other issues you put it, obviously you will be able to determine which one is your best choice. Now, there are several factors we have introduced, and all these factors has certain values, right? Based on the importance of the system, biometric system, which you would like to deploy in an institute, various aspects of the different biometrics are weighted. Because there will be very few of them, now you have to give that each of them has certain aspects, you have to weight them, right? That weight will be used to determine that which biometrics you want to use it. So, each biometric has certain drawbacks, you understand those drawbacks clearly, and note down that these are the drawbacks I have for this biometric state. For iris, these are the drawbacks that you note down, and against each drawbacks you put some weights, say low, medium, high, or one lying between 0 to 10, you put some weights. Further, instead of using 2 error rates, right, because 2 error rates will tell you about the convenience and the security. If you remember, in the last class we have defined what is security and convenience. These 2 error rates will help you to determine this one. Here you can use equal error rate of the training set. The number of false acceptance per 10,000 at the false rejection rate of 10%, this can be one parameter. Another one is number of false acceptance rate per 10,000 at false rejection rate of 1% can be used additional aspects. So, it is here I have written forcibly 10%, you can increase, decrease, whatever it is, but once you define that one, now let us assume that one is the physical access that I want to enter in my classroom, another one is that ATM users. Intrinsic properties, you need required cooperation or not, right. So, these are all some random value I have put, right. Some low required cooperation is low in the case of physical access, because I want to keep the say PTZ camera, and your cooperation is not required, but ATM use you need medium. Social stigma means that suppose I tell you that you have to give your fingerprints, sometimes society does not accept that one. They feel that I know how to sign, why shall I give my fingerprints? See, recently in the TV ad is coming, right, Sarva Shiksha Abhiyan or somewhere, then lady is standing in the queue and then that supervisor is telling, put your fingerprint, and she is telling, no, I know how to sign, right. So, the social stigma is important thing, right, and then population missing. In the case of physical access, I know these people will be coming, missing population will be 0, because these are the people, and but in the case of ATM, coverage is not 100%, very few people are using the ATM, right. So, ATM users population missing is high. Sampling property, inconvenience, if false rejection is there, how much inconvenience will be there. ATM users will have the heavy, because if I am not rejected, I want to withdraw money, I will not be able to get the money, and then obviously that is the reason why I put high. Acquisition time, how much time it takes to give you the data, failure to enrollment rate and failure to acquire rate, right. These are also I have put there some number. 1:1 matching properties, number of false acceptance per 10,000 with FRR 10%, we have written something, and false acceptance rate per 10,000 for the FRR 1% is that, and template size is low and high we have written. Technology properties, installation cost is what you have to see, then computational run cost and cost per match, right. These are the parameters we consider for both the things. Now, if I see with respect to the trait one, so corresponding to the traits we obtain, these are the drawbacks, and finger, face and iris we have obtained, right, these values we have written. Now, these are no, now you could obtain for both the case that for the requirement wise, what are the issues I have noted down, for the biometrics characteristics also we have noted down what are the drawbacks and these values we have put. Now, which biometrics will be suitable? To know that, what I want to do, that I replace this high, low, medium by some value, say 1, 3, 10. If I know this 1, 3, 10 or some values, then score I can obtain the summation over WPI into BPI, the weight for the institute and weight for the biometric state, right. So, if I put that weight, suppose physical access is this and fingerprint is that one, and that weights I have put and I got the total is score is 110. Similarly, you can obtain the other traits, and based on the which is having the higher score, you tell higher score, you tell that it is not acceptable to you, lowest one you want for your use. Am I right? Is it okay? So, using that means you need to know the industrial drawbacks, why I need this thing, how much cooperation I need, all those things you find out, and at the same time you obtain the each biometric traits corresponding drawback values, then you collide them or fuse them, or we obtain the weighted average or weighted sum to obtain the score, the minimum score value you take for your system. The other one, other way of also measuring that which system is better, that is known as xiphon charts, right. Now, this xiphon chart gives you or is measured based on these 4 factors. How much effort is required in your biometric system, right? That can be obtained that by from the training, that iris takes this much effort, fingerprint takes this much effort. By telling, you can tell it is very much effort is required, 0 effort is required, you can easily determine that one. That is important parameters. Non-intrusive, that is it creating the inconvenience to people, how much? Is it a very inconvenience? Every time you are rejecting a genuine person, or no, most of the time? Some parameters you can find out from there. How much accuracy the system gives, and is it inexpensive? Is it how much expensive it is? Right? These 4 parameters you can easily explain in the scale of 0 to 10. Yes, possible. Right? Possible, yes or no? Because how much effort? I give you the 4 or 5 biometric scan sensors, and used by 100 people, they write down in the scale of 0 to 10 for each of them. This is effort, full effort, I need full effort, I don't need much effort. So, 0 to scale 10 scale, and then you make average and standard, you can obtain this one. Inconvenience, how many times it is making the failure to false rejection rate, that you can find out. Accuracy you can easily find out, and then cost, is also important. So, if I know these things, so can I have, this is a will it be, say it is, first one is effortless, the other is a non-intrusive, accuracy, and another one is expensive, right. So, can I have this a 3-dimensional figure on a 3-dimensional structure, that one is the expensive parameter 0 to 1 scale. This is if I have the, this side is 0 to 1, 0 to 1, 0 to 1, right. So, I have a 3-dimensional figure. Now, this 3-dimensional figure, if I can obtain that, what is the total area volume? I can obtain that. So, if the volume is less, and then you tell that this is the better biometrics for you. This is one example as to put it. Now, the term is coming multimodal biometric system. By now you realize, so single biometrics, you know that you have the false acceptance rate and false rejection rate. It will be there, it cannot be 0. You can make one 0, then other will go up. So accuracy cannot be 100%. And another thing I can tell you that from, suppose I have a system which has 85% accuracy, there is a still chance to improve your system to achieve maybe 90%, up to 90%. But suppose I have a system of 98% accuracy, to improve by 0.5%, there will be very, very difficult. So that is the bad part of pattern recognition system, right? So improving by very small amount for the higher percent accuracy things is very difficult. So, but everybody wants that a system I want to deploy which has 100% accurate. So this 100% accuracy cannot be achievable by a single biometric trait. So what we can think that can I use the different biometric traits and you fuse these results to improve your accuracy, right? You combine this, say it may so happen that okay, if I assume that his biometric information or fingerprint information and he has given also the face information, and if one of them is matched, he is allowed to enter, right. So obviously the accuracy will go up. So that indicates that the integration of 2 or more biometrics is required to get the better accuracy. But still it is not proved that multimodal will give the better results than the single biometric. Now better means what? Better means that I have the money in more biometric trait, more money I have to pay, right. So those issues are also there, because cost is also an important parameter. Cost versus the amount of security is required. Now what are the different types of multi-biometrics? One thing can be that I collect multiple samples of the same biometric trait, right, and then you fuse them. For example, I take the 2 IDs data and I use both the results and combine it, or I take the 10 fingers and I match 10 fingers instead of single fingers, and then I should get the better results. What should be my fusion strategy, that is later on, but I combine the result by some methods. Another one is that I have the different algorithms of face recognitions, and each algorithm gives me some results. I combine them and give the results. That is also possible. And another one is that I use multiple biometric traits. That means I take the face, fingerprint, IDs or others and you fuse them. So these are the 3 ways you can think to design your multimodal biometric system. Now how to fuse them? Here I have not mentioned the 4th one, because 4th one we are not interested. Okay, first let us talk about the 4th one. Then I get the sensor data. This sensor data is an image form, right? And another sensor data, say I got fingerprint data, it is in the form of image. Another one is say face data, it is also image form. I combine them, I make one image, right? So fingerprint is having say 100 cross 20, and another one is a face is having 180 cross 300. And I combine these 2, I get one image. That is the lowest level fusion, image fusion, which we are not interested. So first one is that feature extraction level fusion. That means that I got the features from one biometric trait, and say ear is there, ear biometric traits I got the features, and also face biometric trait and I got the features I combine them, I concatenate them, that is possible, or I take the fusion of or some other methods to combine these two, that is possible, feature level. Then another one is the fusion at the matching score level. What it means? That you will be matching your fingerprint with another fingerprint, you got a score, right? And similarly, you matched IDs against another IDs, you will be getting another matching score. Now remember that one matching score may give you the similarity match, the other one may give you the dissimilarity match, or one matching score is lying between 0 to x, another matching score may be giving you the range minus y to z. So both of them you have to normalize it and you make it in one platform and then you fuse it. How you will be fusing, that is different, but some method you will be adding these two matching score to get one matching score, and then using the threshold value you accept or reject, that decision you can make. Third one is that decision level, that suppose one finger biometric state gives you the indication that you are accepted, the other one is telling also accepted, 100% you are accepted, right. Similarly, one is rejected and other also has rejected you, then it is 100% accepted, rejected. The other case is one is telling accepted, another one is telling rejected, then there is a need to decide. So the fusion at decision level. So these are the ways you can fuse that.